Hi everyone, and welcome to episode 33 of SAMA. SAMA is a webinar where we invite an expert to talk about their area of expertise. And today we have Stephanie Seneff to talk about sulfates, the most common nutritional deficiency that you've never heard of. Stephanie Seneff is a senior research scientist at the MIT Computer Science and Artificial Intelligence Laboratory. She has a Bachelor of Science degree in Biophysics, degrees in Electrical Engineering, and a Ph.D. in Electrical Engineering and Computer Science. In recent years, Stephanie has focused her research interests in biology. She is concentrating mainly on the relationship between nutrition and health. Since 2011, she has published over 30 papers, that's right, 30 papers, together with colleagues, in various peer-reviewed medical and health-related journals on topics such as modern-day diseases, i.e. Alzheimer, autism, cardiovascular diseases, analysis and search of databases of drug side effects using NLP techniques. We'll have to talk and explain to me what NLP stands for, Stephanie. And the impact of nutritional deficiencies and environmental toxins on human health. As I said in this episode, you'll learn the important roles of sulfate in the body and the mechanisms by which glyphosate, the active ingredient in Roundup, disrupts sulfate homeostasis. So it's going to be a riveting SAMA today, and Stephanie, welcome aboard. So please tell me, what is sulfate?
Yes, well, it's very interesting. Sulfate is the fourth most common anion in the body, a negatively charged molecule. Really, really important in many, many ways that it's used in the body. It's a sulfur atom. Sulfur is, in the periodic table, one of the elements. Sulfur sits right underneath oxygen, so it has the same kind of power that oxygen has to help you. And in fact, it was probably preceded oxygen in the development of life. Life was sulfur-based before it was oxygen-based. So we have enzymes that go way back to, almost prebiotic that work with sulfur. Sulfur gets oxidized. So one thing interesting about sulfur is that it has 6 different, it can be -2 all the way up to +6 in its electron state. So it has a lot of flexibility to move around in terms of giving up and taking back electrons. And that's very important for all kinds of reactions. But one thing sulfur can do is to grab oxygen. So you can make sulfate by putting 4 oxygen molecules together with sulfur. And this allows you, in fact, to transport oxygen in a very safe way. So that's one very interesting thing about sulfate. It can carry oxygen. And then it shows up in all kinds of interesting places all over the body. It's in the blood. It lines the blood vessel walls. It decorates the walls all along all the arteries, the veins, the capillaries. Very, very important. They're both for allowing the red blood cells to slide very easily through the capillaries, and also for providing energy. And it provides energy to the cells through water. So it's incredibly fascinating stuff that I've been learning. I've been obsessed with sulfur and sulfate for probably the past 10 years. Actually, most interesting is I started studying autism and heart disease at the same time about 10 years ago. And the first thing I zeroed in on was sulfate deficiency in both. I was so astonished. So, I mean, it is so, so critical for the body. It also, because it provides the electricity, it also means that it's important for the mitochondria to produce the energy. It's also important for the lysosomes, which clear the garbage. So, a cell is living. It needs energy. It needs to be able to get rid of its garbage. If it can't do those 2 things, it's going to die. And sulfate provides both. It is essential for both.
Does your body turn sulfur into sulfate?
Yes, it does. It's so cool. It turns it into sulfate, and then it turns it back into hydrogen sulfide gas. So you go between hydrogen sulfide gas is H2S, 2 hydrogens and a sulfur. That's the -2 state. Sulfate is SO4, and yes, both of them are -2. H2S is neutral, but sulfide is -2, and sulfate is -2 also, electric charge. They're both negatively charged, but sulfate is carrying the oxygen and sulfide is not. So you basically can put the oxygen onto the sulfur, carry it around in the body as sulfate, and then later on give it up and release it as oxygen when you, it's the point where you want to actually use it to like, you know, break down glucose and generate energy. So oxygen, it's a way to transport oxygen, which is so cool.
It's a lot. It's a lot of information all flooding in. So
It's going to be deep science all the way. I'm sorry to say that, but it's so
no,
fun.
no, it's good. Yeah. So sulfur is a way of transporting oxygen into the cells, or just right where the cells are?
Well, it just kind of carries it around. So for example, the red blood cells. So this is the part that's really fascinating. And we wrote papers a few years back on cholesterol sulfate. I mean, that's a super important sulfated molecule that also has not gotten enough attention. It's in the blood. You know, DHEA sulfate is similar. DHEA, I forget dehydro. I always can't remember. It's a very complicated DHEA, but that's another sterol-like cholesterol. It's kind of a derivative of cholesterol. DHEA sulfate and cholesterol sulfate are very prominent, you know, molecules that are carried around in the blood. The cholesterol sulfate, both of them probably do the same thing. Cholesterol sulfate goes into the membranes. In fact, it's produced by the red blood cells, and they put it into their membranes in order to protect them from, you know, all the marauding oxygen and glucose that can cause damage. So glucose and oxygen in the blood are dangerous. They're essential and dangerous. Glucose causes glycation damage. You know, that's the sort of diabetes. When you have hemoglobin A1C is high, you've got diabetes. That's an indicator of damage to the hemoglobin in the red blood cell by glucose. But if you've got a red blood cell with lots of sulfate in its membrane, the sulfate builds a beautiful water shield, a structured water. I like to call it liquid ice, a liquid ice shield around all the suspended particles that have enough sulfate in their membrane to do that. And that gel, that layer of structured water is like a Superman shield around this particle, including the LDL particles, for example, that are, you know, you go get your cholesterol tested, you've got high LDL, okay, you've got to go on a statin drug, or you've got worse than that, high levels of this, you know, small, dense LDL particles. People probably know about that. Their doctor says, oh, you've got this really high level of these small, dense LDL particles. That's really bad. You need to be on a statin drug. That's because they got damaged. They got damaged by oxygen and by glucose, glycation damage, oxidation damage, and the liver won't take them back because of that damage. And so they're just troublemakers at that point. But the reason why you have them is because you didn't have the proper shield to protect the LDL particle from attack by those elements that are in the blood that are going to cause trouble. So it's so neat that the sulfate is needed around all these suspended particles, including the red blood cells and the platelets, to protect them.
Right. Quite a few years ago, you used to get lollies which were made from sulfur.
Oh, really?
Yes, I know that in Ireland they had these lollies. And if you had a boil on the back of your neck, or elsewhere, I suppose, you'd swallow one of these lollies and the boil would just disappear.
Oh,
so
that's interesting.
Would that be a similar mechanism? Where
I suspect so. I mean, so what's really happening today, I mean, in the United States is very serious, I think. And of course, elsewhere as well, but the US is best at this, which is poisoning people with glyphosate. Glyphosate is the active ingredient in the pervasive herbicide Roundup. And I identified early on when I first started looking at glyphosate, I started suspecting that it was the reason why we had this sulfate deficiency problem. I had already identified sulfate deficiency in Alzheimer's, in autism, in heart disease, and probably in many, many other diseases, the gut dysbiosis, the rheumatoid arthritis, I mean, and even cancers. Sulfate deficiency, I think, is a driver behind all of these diseases, and I think it's being caused, the epidemic is being caused by glyphosate. And I've been studying to figure out all the different ways. Glyphosate disrupts sulfate in so many different ways, it's truly amazing.
Okay, so just to clarify things for our viewers, what you're saying is that a spray that farmers are putting on their crops is causing us to have autism, diabetes, and all the other chronic diseases, or possibly most, if not all, of the chronic diseases, the modern day diseases that we're now experiencing, is by a spray that people are putting on their crops. Is that right?
That is absolutely right. I think glyphosate is by far the biggest problem. There's many, many others, of course. We live in a chemical toxic soup right now, along with the EMFs. I mean, it's in the vaccines. I mean, there's so many different things that are destroying our children. I really feel very discouraged about the future of the United States because of the state of our children. I mean, the most recent number is 1 in 36 for this autism rate. It's the highest that we've seen. It keeps on going up. There's no end in sight. And the government is, doesn't care. I mean, we get this new number. It's just a few days ago, this new number came out, 1 in 36, and you don't hear anything about it in the news. It's like, that's fine, and I do not understand why that's fine. I really do not understand that.
It should be 0. So why do they put this Roundup on plants?
Yes, well, it was a great idea, and it's a wonderful thought if it's true, which is that this is a chemical that kills all plants, pretty much all plants, except for those few that have been engineered to resist it, and that's where the GMO technology comes in. Okay. But it's completely harmless to humans. Don't worry, it doesn't harm us at all, but it kills all plants. And that doesn't make any sense to me, because there's a whole lot of overlap between plant physiology and metabolism and animal. You can't have a chemical that kills all plants and doesn't hurt animals. You simply cannot. And glyphosate hurts animals in a way, and plants, in a way that is insidious and cumulative, very, very dangerous and very subtle. So you don't notice it because you don't necessarily get a bellyache when you eat food that's contaminated with glyphosate. But what happens is that it slowly works its way into all your tissues. It builds up at the highest concentrations in the bone marrow and the bones and the bone marrow. And Monsanto found this out in their early studies. They knew it was accumulating throughout the body. They tested it, all the tissues. They found it everywhere they looked, but especially in the bone marrow. And this is very serious, because the bone marrow is where you get the new stem cells that come out, and they go to the site of injury. If you get in an accident and you have, let's say, a brain injury, the stem cells come out to help to heal, and they carry glyphosate on their backs, and they deliver it to the site of injury and make it worse. It's very devastating. So everything becomes every time you try to heal something, you can't do it because you're delivering glyphosate to the site.
So if a product was found to have that, well, they call things now side effects, unwanted effect, how did it make it to market?
I know. Well, Monsanto did a lot of sleazy things back then. Anthony Samsel and I have been working together, and we've published 6 papers so far. We're working on a 7th one, which we're very excited about. Very difficult and very complicated things that we're figuring out with respect to glyphosate in this 7th paper. And he's just doing really, I think, great research. He's trying to get a hold of bile acids now, because Monsanto, so he has all these documents, and one of them, they're unsearchables, and there's huge amounts of them, so it's sort of hard to dig through it to find the gold. But he found one paper where Monsanto discovered that there was high levels of glyphosate in bile acids. And this has triggered a very big interest in that. So we're writing about bile acids this next time, but that totally messes up the gut. It messes up not only the ability to digest fat, but it also screws up the gut microbiome and causes inflammatory gut and leaky gut and all of that. So I think it's directly connected to that. That's where all these diseases start, is with this gut dysbiosis. And I forgot your question, because I think I'm not necessarily answered it. I got wandered off.
I was just wondering how it could make it to. I mean, each time we talk, it sort of spawns off a whole lot of questions. I was going to ask you what microlasses is.
What
microlasses?
Microbiome, the microbiome. Bile acids. Bile acids are produced by the liver to digest fats. They're really fascinating, and I've been reading all about bile acids lately. Biology is a huge space, and there's so much information, and you get, it's so exciting to do the research. I love the research, because there's so many papers out there, and you can just start to work out the space and figure out, and looking in the context of what glyphosate does and working out and linking it up to what you find in the literature. It's so amazing how easy it is actually to tell the story once you start looking at the literature. The research literature has the answer in it already as to how glyphosate is damaging us. Monsanto had done some studies where they saw some very dangerous, things they should not have ignored, and the bile acids was one of them. Also, the fact that they found that they did radiolabeled glyphosate, and they found it in all the tissues, as I said, and they also found out that they couldn't identify it as glyphosate. Like, for example, in the muscle tissue, this is very important. It may sound obscure, but it's extremely important. They found glyphosate. They found radiolabel, because they had when you label it, you know it's there. You have a question.
Fast. Yes. I should stick up my hand every time I've got a question, because it's a subject that you're absolutely passionate about, and because you've been involved in the research for such a long time, you say some terms which I've got no idea about and quite possibly.
Okay, that's
So
good
maybe
that
I'll
you
stick
stopped
my hand
me.
up and ask, radio traces. Is it like radioactive?
Radio label, yeah. So that's actually really a cool way that they can trace things. They change the molecule by replacing, say, carbon with a different kind of carbon that actually emits a signal. That's the radio labeled carbon.
Okay.
And that allows you to trace the signal. So radio labeling something is a really neat way to actually be sure you know it's there. Once you put that in, you know it's there.
Do they use like an MRI machine?
Yeah, yes, exactly.
Okay.
You know how you drink some of that, like the gadolinium drink and stuff, that gives you a radio label, and you can trace it. And so they do that. So they do that in these experiments where they're trying to figure out what happens to a molecule, like a toxic molecule like glyphosate. If they're going to do a study, an appropriate thing to do is to feed the rat a radio labeled version of that molecule. And then you can look for the radio label to see where it went. And that's how they found out that it went into all the tissues, because the radio label was there. But then you can also take that same tissue, say muscle tissue of a rat, and you can say, well, let me go test for glyphosate. So if you didn't have the radio label, you wouldn't know the glyphosate was there unless you test it through this other method, which involves spectrophotography. This is, methods that they use to look at a signal, a spectral signal that molecule emits, that you can tell if it's there or not. The really interesting thing is that they had the radio label, so they knew the glyphosate was in the muscle, but they couldn't find it using the standard methods. This is very dangerous because right now we can't find glyphosate in proteins. Proteins are where glyphosate is accumulating. Anthony and I both strongly believe this. Glyphosate is getting into the proteins by mistake in place of the amino acid glycine, which it is an analog of. This is incredibly important because it explains glyphosate's bizarre and complicated effects on the body, because it messes up all the proteins in the body whenever it gets into those proteins in place of glycine. Does that make sense to you?
It does.
Yeah.
I was going to ask a question just a little while back. How good is it to use? When rats are being used for laboratory tests, do they mirror the results of the humans? Because we've got a different biology.
Yes, it's just not 100%, but there's a lot of, you would be surprised how similar we are to rats, actually.
I think quite a few people I know are quite, well, there's one in particular that's very similar to rat.
Yeah, a lot. So they do the studies on the rats, obviously, because we don't value rats, so we don't mind so much that we're giving them a really horrible life. But it's nasty studies. I mean, it's really sad what we do to the rats with these studies. But we do learn a lot because of them. And we can learn a lot about humans, but not always. Sometimes the rats are enough different from us that you can be misled, and you'll miss something that is unique to humans that rats don't have, and then people don't end up realizing about that. I think that's what's going on actually with cholesterol sulfate. We should get back to our topic, I suppose, here at this point. We've wandered off. But cholesterol sulfate is synthesized in the skin in response to sunlight. I think that is super, super important. That's one thing that I learned early on. We wrote papers on this. It's really fascinating.
So the sunlight does the conversion food. Is it associated with the vitamin D, or is it?
Yes, well, it is. Well, the vitamin D is very connected to cholesterol, because they're almost the same thing. When you look at a cholesterol molecule and a vitamin D molecule, you have to stare at them for a while to figure out what's different. They're very similar,
Gosh.
And it's interesting that cholesterol is such a demon. I mean, we hate cholesterol, which everybody's trying to lower their cholesterol, which is a big mistake, by the way. And yet vitamin D is like, we're popping vitamin D pills, and it's kind of strange because vitamin D is produced from cholesterol. So without cholesterol, you can't make vitamin D.
Vitamin D, okay, right. So you're taking drugs that prevent you from taking from your body from converting sunlight to vitamin D.
Yes.
And if you're living in a country which doesn't have much sunlight, then so you're getting a double whammy then.
Yes, and we have an absolute epidemic in vitamin D deficiency. It's right now in America, so many people are popping vitamin D pills because they're trying to get their vitamin D levels up. And one of the reasons for that deficiency is because of course, glyphosate, I think, is a major player in that problem. And an easy reason is because of the cytochrome P450 enzymes in the liver, which glyphosate suppresses. That's been shown in rat studies. Those enzymes activate vitamin D, and they also make bile acids. So that all links together. You can't make the bile acids, you can't activate the vitamin D. Without the vitamin D, a lot of things go wrong. And without the bile acids, a lot of things go wrong too. So there's a big hit right there.
It's such a complicated topic.
I know. I told you.
But everything's interrelated. And it appears to me that Roundup is like taking away a little piece of the puzzle, and the whole thing's falling apart. it's mimicking other amino acids. Is that right? Did I
It
get that
is.
right?
That's what it really, when it was just a really aha moment for me. I remember so well this phone conversation I had with Anthony. I think it was it now 2 years ago in this time of year, December. I know it was December, probably 2 years ago, when he said, Stephanie, I think glyphosate's getting into proteins by mistake in place of glycine. And when he said that, just a light bulb went off, because I knew glyphosate was disrupting glycine. It's clear. It is a glycine molecule, by the way. Glyphosate is a complete glycine molecule. It's actually a pretty simple molecule, except it's got some extra stuff stuck on the nitrogen atom. So it's a modified glycine. Glycine is a super, super, super important molecule in the body in so many different ways. It's a neurotransmitter. It's an amino acid. It goes into proteins. It's involved with the bile acids, because glycine is stuck onto the bile acids. When they're produced by the liver, they're shipped out after they've been attached to either a glycine or a taurine molecule. Really fascinating stuff. It's just amazing what biology does. So when the bile acid is hooking a glycine molecule on, it grabs glyphosate by mistake. So now you've got a glyphosate conjugated bile acid. And what that's going to do is it's going to destroy bifidobacteria in the gut. The bifidobacteria are trying to take the glycine off, but they're taking off glyphosate instead. So they're getting a lot of exposure to glyphosate, and they're getting killed off. And we have a huge problem with insufficient bifidobacteria in the gut, which then causes all these pathogens to grow, like Clostridia and mostly Clostridia pneumonia, Clostridia, Pseudomonas aeruginosa, and C. diff, Clostridium difficile. All these different nasty microbes start growing because of the bifidobacteria being clobbered by the glyphosate.
Is that the reason why there's more gluten intolerance?
Absolutely. That's so perfect. I mean, that one is a no-brainer in my opinion, because gluten, and we didn't get into this, and you asked me, but I didn't follow through. How is glyphosate showing up in our food? One is because of these GMO crops: corn, soy, canola, sugar beets, and alfalfa are all engineered to resist glyphosate. So they can pour it on the crop anytime they want, and it won't kill it, but it kills the weeds. Very easy way to control the weeds, makes crop growing very efficient. But there's a whole other set of crops, and wheat is one of them, where the glyphosate is more and more being used routinely right before harvest. They spray the crop with glyphosate to kill the crop, intentionally wanting to kill it. It goes to seed. In its last gasp, it produces more seed. It sort of synchronizes the harvest. You might be chasing a snowstorm. You want to get the crop out before it freezes. There's reasons why you might want to do this that are sufficiently compelling, and especially because glyphosate is harmless to humans. You pour it on the crop right before harvest. And now the wheat has got glyphosate in it. And this is, it's really, beans are incredibly high levels. Garbanzo beans and chickpeas, lentils, incredibly high levels of glyphosate. And wheat and barley, unfortunately, that means beer, so wine, all these things have glyphosate in them.
They do that for grapevines as well.
Yeah, unfortunately, it's in wine, which is disappointing. Or you got to drink organic wine, organic beer, eat organic bread. I mean, organic bread is not that easy to find, No. And so, but the wheat is contaminated with glyphosate. The glyphosate is in the wheat protein, in the gluten, which makes the gluten hard to break down. Glyphosate is also in the pepsin and the trypsin that are the digestive enzymes that break down the gluten. And trypsin has like 3 different regions where it has essential glycine residues in it. You swap out glycine, put in glyphosate, the enzyme is broken. So now you've got a broken digestive enzyme that can't break down the wheat. The gluten ends up as an undigested protein, which then causes a reaction in the gut. It's like, oh my God, undigested. It sends off alarm bells to the gut lining, and they start releasing all these molecules that are signaling molecules that end up opening up the gut barrier. You allow water in, you end up with diarrhea, and then you end up with things getting out of the gut through those leaky gut barriers. You end up with proteins getting out into the general circulation, and then causing autoimmune disease through something called molecular mimicry, which, because those proteins resemble proteins in your body, and your immune system is on high alert, it ends up attacking your own tissues, and you get all kinds of different problems. A gluten intolerance is a complex condition with lots and lots of comorbidities, they call it, all kinds of different, reactions that you get. But we've got it's just amazing now. You go to the grocery store, there's this huge section that has all this gluten-free this and gluten-free that. people are just allergic to wheat, allergic to milk is another one, casein, same thing. The cows are putting the glyphosate into their milk.
Oh, because the grass
they're getting tons of glyphosate in their feed because they're eating all this GMO Roundup ready corn and soy. And then they're putting it into their milk, and then it's getting into the casein. And the same story is happening there. We have a huge problem with food allergies, not just the wheat and the milk. We've got the peanut allergy, the soy allergy, we've got corn allergy, we've got allergies to meat. I mean, it's all because glyphosate is getting into those proteins and making them allergenic. That's what I think.
That's shocking. Well, can people use the glyphosate sprays and then leave the spray for a while before using it? It's supposed to go into the roots and then disappear into magic land.
Yes, that's not true either, unfortunately. In fact, there's a brand new study that just came out looking at the glyphosate left behind in the crop residue. So lately, one of the things they advertise about glyphosate is you can use this, what's it called? I've lost the name now. You do agriculture in which you don't stir up you just leave it all very, you used to have to sort of stir up the soil and stuff. I've forgotten the term. I don't know, it's a little bit of a senior moment there. But kind of agriculture, we just leave it all in place. And instead of sort of pulling up the weeds and stuff, you just leave it all in place. And of course, you put the glyphosate on there so it poisons all the weeds, everything dies. And you just leave all the residue from the crop. Like you spray the wheat with glyphosate, it dies. Yes. You leave the residue there in place. No-till. I got it finally. No-till agriculture, that's called. No-till. Sorry, it took me a while to get that. So all that residue stays there, but that residue has got glyphosate in it. And Monsanto claims glyphosate is very quickly metabolized by the microbes in the soil. It disappears in 2 weeks. It sounds wonderful, but it's not true. It's a lie. And these people found over a year later, there's still glyphosate because it's in those proteins, in those plants. It takes it a very long time to get broken down.
Well, how long would it take?
I don't know. I mean, I suspect years, in some cases. Gosh. It depends on how well protected it is from the microbes. And of course, also you could be killing off the microbes that can metabolize it. It's actually interesting, this research on how to fix the soil going on right now once you've got the soil ruined by glyphosate, because it ruins it in so many different dimensions. But the way you fix the soil is the same as the way you fix the gut, which is really interesting. You've got these clinicians who are working on healing the gut for people. Yes. And then you've got people who are working on fixing the soil from all the damage from glyphosate and all the other chemicals that it's exposed to. And it's the same process. You give them probiotics, you find fulvic acid and humic acid, which are organic matter from pristine soil. You've got to find some soil on top of a mountain somewhere, some really good soil that you put in there, which first of all gives it this organic matter, which is very useful fuel for the microbes. And then you give it probiotics also. You might even want to give it microbes, specific microbes that can metabolize glyphosate. So for example, Acetobacter is one of the very few microbes that can clear glyphosate. And so if you eat vinegar, and I do this very routinely, apple cider vinegar, Bragg's organic apple cider vinegar, put that on your salad, and you're giving you eat your salad, and then you've got your vinegar there, you've got your Acetobacter. Now when you get your glyphosate in your food, which you're trying very hard to avoid, but if you do, that Acetobacter can clear it. And not very many microbes can do that, because there's very few microbes that know how to break that CP bond. That glyphosate has this CP bond, which is very difficult to break, which makes it very difficult to break down by the microbes. So it really depends on which microbes are in the soil as to whether it's going to get cleared or not.
Okay. In case you're wondering, this salmon is going very well, because I was thinking, well, this is talking about all the negative things. We'll talk about negative things for the first half hour and then talk about positive things. And we've just cut into the second half. And
good.
you told me something very positive that people can do to.
Yes.
So that's apple cider vinegar, but I guess it'll be like an organic apple cider. It's got to be one that's truly brewed, not just flavored.
Yes. Ideally unfiltered organic. Bragg's is a good product. Bragg's unfiltered organic apple cider vinegar. I recommend that highly. A couple other things I recommend highly are curcumin, turmeric. Do you know about turmeric?
Yes, that's one. It's quite often used in Indian foods, isn't it?
Curry, yes, Indian curry, and Indian people have a low rate of Alzheimer's disease. And a lot of people believe that's because they get so much curry in their diet. So I really like turmeric, and I also like garlic. Garlic is a super source of sulfur. So I think, in my opinion, you cannot eat enough garlic.
Now, you were surprised when I told you that people in the northern hemisphere actually used made sulfur sweets. What many people don't realize is that flowers of sulfur is basically dug up sulfur from the ground, especially if they haven't added some stabilizer to it. The sulfur that you spray onto plants can be used, to kill aphids and everything else. They can be just consumed with some maple syrup. But I wanted to ask you, Stephanie, is that a good thing to do in your opinion? Because it's like a spoonful of sulfur, pure sulfur.
Exactly what sulfur is it? I don't quite understand that.
Well, it's elemental sulfur, so it's a yellow powder.
Yeah, it's not MSM, right? Methyl sulfonyl maybe. I don't know of elemental sulfur. I would be worried about. I don't know what would happen if you took elemental sulfur. That sounds very extreme. But methyl sulfonyl is highly recommended by a lot of people. People have sworn by it to say it's really helped them, and and you can take that like a powder. You can just mix it in your water and drink it.
Yes.
And it's cool because it's got both sulfur and methyl, and both of them are problematic. So very interesting, actually. And I should probably tell you this story. I hope I'm not getting way too much biology, but this is so cool.
I'll try and keep up.
Yeah, because the gut microbes do something really wonderful. They do many wonderful things for us. That's one thing we're realizing. They make all these things that we can't make. And that's one of the things about glyphosate, because glyphosate, the key enzyme that it disrupts in plants they claim is the shikimate pathway. And I believe that. It messes up the shikimate pathway. That produces the aromatic amino acids. These are three very, very important. I mean, all the amino acids are important, but these three aromatics aren't produced because of the blockage in the shikimate pathway by glyphosate. But also, glyphosate disrupts the synthesis of methionine by the gut microbes, and that comes from sulfur. Methionine is the key core, is the center stone of the sulfur containing amino acid system. So there's several different sulfur containing amino acids: methionine, cysteine, homocysteine, and taurine, all of which are really, really important. But the gut microbes make the methionine, and then we can make all the rest once we have the methionine, but we can't make the methionine. Okay. And glyphosate messes that up. It messes it up in plants, it messes it up in microbes. And so without that methionine, we become deficient in methyl groups as well as in sulfur. And methyl sulfonylmethane provides both. So that's what's really cool about it. It can help you with both the methyl supply and the sulfur supply.
Okay. I understood some of that, which is not. Now, on the we're living in a toxic world. We go to the supermarket. As sure as Santa's coming at Christmas time, we know that the crops are going to have some glyphosate on them. What would you recommend people do to eliminate? We've already covered the apple cider vinegar,
yes.
And
I mentioned the fulvic acid and humic acid, which you can actually buy, and people can eat that, and it's very good for you. I think that's a good way to heal the gut also. The fulvic acid and humic acid are these complex sugar change molecules that are produced by plants, and they end up in the soil, and then they're organic. That's the organic matter in the soil. And it was interesting, a study on cows showed the cows were sick. They showed they had high glyphosate levels in their urine. Yes. And they treated them with fulvic acid, humic acid, and bentonite clay, and vinegar. Not vinegar, but sauerkraut juice, which is probably even more powerful than vinegar. But sauerkraut juice, that's also good. So all the fermented foods are good. Okay. And these organic matter, they bind. Apparently, the organic matter binds to the glyphosate and allows it to be excreted through the feces. That's what I've been told.
Okay. And the clay just helps to bind it all together.
I think so too. The clay binds. Those things all bind to the glyphosate, pull it out through the feces, because you want to try to keep it from getting into the body, so you need to kind of grab it. You need to have microbes that can break it down, and you need to have things that can bind to it. And if you can do that, then when you're eating the glyphosate, you'll have less of a chance of getting it into your system. And of course, you want to heal your gut, because when your gut's leaky, then the glyphosate's going to leak too, That's when it gets really dangerous. Once the gut is leaky, the glyphosate goes into your system and it goes everywhere. And then your brain becomes leaky too. Once your gut is leaky, the gut microbes communicate with the brain and the brain becomes leaky. Now you've got a chance to get the glyphosate into the brain, which is just going to be devastating.
What would the effect be from that?
Alzheimer's, for example, Parkinson's disease, autism. All these things.
All the things that are on the way up.
Yeah, they're going up dramatically, exactly in step with glyphosate. I mean, autism is a perfect match.
Wow. Now the fulvic acid, I think you said.
Yes.
Are these things? Are these like tablets that you buy? Because what I find is that most of the things that sort of you take for health, you've got to pay a lot of money for, and in the form of a tablet, and they're dried and they're concentrated. But
I know it doesn't feel very natural, does it?
No,
I don't like to take tablets. I will say I take only one tablet. I don't take any drugs. I don't take any nutritional supplements, except for one, which is turmeric, and it comes in a capsule, and I take that as a capsule. It's an organic turmeric, a really excellent product. I unfortunately don't remember the name of it, but I have it written down, or I have my bottles. I could show it to you if I could get my husband to go get it or something. But anyway, it's turmeric.
Would it have a different effect than if you added this turmeric into your food?
You probably could. I mean, of course, you can use. We also eat curry a lot. We have a curry chicken dish that we love, and you put coconut curry chicken.
Yes.
It's very good. Yes. And as I said, the garlic. Curry is actually very interesting. Turmeric has a sulfur story to it. It's very interesting because turmeric actually gets sulfated in the gut, and then it goes to the liver as a sulfated product, and then the liver says, thank you very much for the sulfate, and then sends the turmeric back around again. So the turmeric goes around and around with the bile acids. The turmeric goes around and around from the gut to the liver, each time carrying a sulfate molecule on its back and delivering it to the liver. So the consequence is that the turmeric supplies the liver with sulfate. And, resveratrol is like that too. Many of these polyphenols, all those, things that are supposed to be so good for you that are in that class, carry sulfate, and they deliver it to the liver. And so people have said, oh, well, this stuff can't really possibly be good for the brain because it never goes into the brain. People have done studies. The turmeric doesn't go to the brain, so how could it possibly be helping it? And the thing is, it doesn't need to go to the brain to help it. All it needs to do is to give the liver the sulfate, and the liver can carry it from there. The liver can deliver the sulfate to the brain, and everybody's happy. So it's really the sulfate that's key. The garlic provides the sulfur, and turmeric carries the sulfate. So both of them are important for helping to deliver sulfate to the system.
Right. I guess it's important to ensure that both the garlic and the turmeric neither have been sprayed with this.
I know. Organic is key in both cases. And we buy tons of organic garlic. We get these whole cloves of garlic organic. Luckily, we can get them at our grocery store. Of course, eating organic is very important. Now, I don't know where you live, but in the United States, fortunately, organic has really blossomed, and it's been growing exponentially in step with the exponential rise in glyphosate. The demand for organic has been growing. We've had to import a lot of our organic food because our country can't keep up with the demand. But you can get almost everything, or at least enough things organically. We've had to give up some things because we can't find them in an organic form. We will not eat it if we can't find it organic.
Gosh, okay, so that's important.
And that includes spices. We buy organic spices. We buy organic wine, organic beer. Organic beer is sometimes difficult to find.
You had mentioned before the function of vitamin D, and going out in sunlight help your body.
Yes.
Now, is it therefore important to have regular dosage of sunlight?
Absolutely. I am a sunlight fanatic. I love the sun. We escaped to Kauai in the winter. I'm very fortunate to have a second home in Kauai, so we're there now. Right now I'm in Taiwan, but that's a trip. So we're going to go back to Kauai tomorrow, actually.
Yes.
And lots of sun. And I really believe we have all of our cars have been convertibles now for many years. We just only buy convertibles. And so we always put the top down, even when it's like 45 degrees. Sometimes if it's a bright summer day, bright winter day, it doesn't matter to get that sun. So, because when you're driving, it's a great time to be able to get sun. It's a very convenient way to get sun. Just because you're going to be out, in the traffic anyway, you might as well take advantage of that time to get sun. So
it's a good excuse. I can't think of a better one. But if you're living in a country that doesn't have much sunlight, what can you do?
Yes, I know that is an issue, and I don't have a good answer. I want to recommend sun lamps. You can get full spectrum sun lamps, which I have to be a little cautious because I'm not sure whether that could cause, you have the issue of cancer. It's interesting that actually skin cancer melanoma skin cancer has been going up in step with the increase in the rise of the use of sunscreen. It's very, very interesting. Very good match. Very good match between sunscreen usage and skin cancer, which makes no sense, right? It makes absolutely no sense. It makes you think that the sunscreen is causing the skin cancer. And I think that may be true because sunscreen contains, well, especially the high-end ones, they contain this aluminum as a to sort of emulsifier to make it so that it's not a white paste. It makes it into something that sort of disappears easily into your skin. You put this aluminum in with these it's titanium and zinc oxides. You put the aluminum in the zinc, and that helps to make the titanium and zinc oxide be transparent and more, less pasty, so it's easier to apply. And the aluminum goes right into your skin, and it gets into your cells, and it prevents the cells from making sulfate because it disrupts enos. Enos is the molecule that we believe is making the sulfate in response to the sunlight, and enos is going to be clobbered by either glyphosate or aluminum. Both of them clobber it, so that when you're exposed to these chemicals, you can't make the sulfate. And the melanin also, which is the skin tanning agent that should protect you from the sun, is a direct product of the shikimate pathway, which glyphosate disrupts. So you've got a deficiency in melanin, potentially, if you're exposed to glyphosate. You've got the aluminum in the sunscreen. And enos is a cytochrome P450 enzyme, so it gets wrecked by both aluminum and glyphosate. Both of them disrupt these cytochrome P450 enzymes, which are super important enzymes in the liver for detoxifying other chemicals, but also is used in enos. Enos is a member of that class. It gets disrupted by both the aluminum in the sunscreen and the glyphosate in the food, so it can't make the sulfate, and the melanin's not there, so you can't protect yourself. So now you've got a real vulnerability to skin cancer, and you're not able to keep up with your cholesterol sulfate supply. So it's a huge hit.
That's a shock. I didn't realize it was so profound. And you can't go into a supermarket, almost can't go into a supermarket and buy an aluminium-free deodorant, for example.
Yes, exactly. And so,
shocking.
You're sort of stuck between a rock and a hard place in a way, but
Well,
we should be more willing to accept body odor, I think, because, people can get breast cancer just from using, aluminum based.
That's right, at that location, that's right.
Mm-hmm.
So, but is titanium dioxide dangerous?
Well, I don't know about the titanium so much. The aluminum part is.
Yes,
Titanium might be too, but I don't know. I haven't studied that enough. I don't know it. I think it's more the aluminum. So I think you can get the one that doesn't have the aluminum, but then it's more of a white paste. You see it on people's noses sometimes, because the nose is very vulnerable. I've gotten in trouble with my nose on a few occasions. I'm not careful enough, and I'm mad at myself when I do that. I'm not encouraging people to go ahead and get a sunburn. I'm not talking about that. You don't want to do that. So you have to be, and you can build up a nice tan. If you've got the melanin, you can build the tan. But if you don't have the melanin, you won't tan, and you won't have the melanin if you got the glyphosate. So you can really get in trouble. It's a complete cascade downward. It's a hole that's very hard to climb out of once you've been chronically poisoned with glyphosate, and you've got it all over your tissues at that point. So how do you get rid of it? It's just very difficult.
Okay. Now we've got some questions in. A lot of them we've covered already. We've just covered the sun exposure. This person was asking, how can sun exposure help optimize cardiovascular health?
That's a great question, and I have a great answer. I've written several papers on that. I'm so excited about it because I'm absolutely certain now, I'm really confident that I'm right, that heart disease is a cholesterol sulfate deficiency problem. Which people go, that can't be true, right? Well, cholesterol's the bad guy. How can that be true? And the reason why the cholesterol is piling up in the plaque is because it's waiting there to become cholesterol sulfate. It's ready to go. And as soon as there's sulfate is the bottleneck. As soon as there's sulfate available, boom, it can be released, and it can be shipped out to the blood, delivered to the heart, and also delivered to the vasculature in the heart, so that you can make the heart healthy, both having a healthy blood supply and being healthy itself, because both the heart muscle and the vessels all over the body, but particularly, of course, the heart's very important, need that sulfate and the cholesterol in order to be healthy. And so it's really cool. And actually, you can tell from the research, homocysteine, is a much better marker of heart disease than high serum LDL. High serum LDL is the high cholesterol problem. They put you on statins. Slow
down. Which is a better marker for the health of your...
Homocysteine is extremely highly correlated with heart disease. High serum homocysteine, having too much homocysteine in your blood
Yes.
is a marker. Homocysteine is a very interesting molecule. It's a sulfur-containing amino acid. And it becomes high when you have a methionine deficiency, which you have because the gut microbes can't make the methionine, and also because all kinds of other things are messed up. But methionine is deficient. There's some B vitamin problems that glyphosate introduces that's going to cause you to have this high homocysteine. Homocysteine can become sulfate in the artery wall if you provide it with superoxide, which is it's a toxic oxygen. You have like what they call reactive oxygen species. People who know biology know about that, but you've got this inflammatory situation where there's lots of superoxide is a oxygen on steroids sort of, and you can use it to make sulfate out of homocysteine. So homocysteine actually triggers this inflammatory response in the artery wall, which causes damage because this oxygen is dangerous, but it produces sulfate. So it's because the enos isn't working and the sulfate is deficient that now you have this sort of alternative method to make the sulfate from the homocysteine. And as soon as you make it from the homocysteine, then you're going to be able to grab that cholesterol out of the plaque, stick it together with the sulfate, and then use it to deliver cholesterol and sulfate to the heart. So it's positioned. So these plaque regions are at the entry, they're at the big vessels that are going directly into the heart. It's very strange to think that it would be a good idea to block the arteries that are supplying the most important organ in the body. It doesn't make sense that biology would do that. But the reason why it's building up that plaque is because that heart so desperately needs that cholesterol sulfate that it's got to be ready to go. So it's sort of piling it up like a squirrel would hide nuts. It's saving this cholesterol to make it available to become cholesterol sulfate as soon as that's happening. But then the homocysteine, in order to provide the sulfate, has to also provide damage through this inflammatory response. And inflammation is like people write about inflammation is behind all these diseases, the rheumatoid arthritis and inflammatory gut. All this is inflammation. Inflammation means superoxide. Superoxide means an opportunity to oxidize sulfur. You take that hydrogen sulfide gas, H2S, and you turn it into SO4. SO4, 4 oxygen. So you've got that superoxide to turn the sulfur into the sulfate that you need desperately to be able to make the cholesterol sulfate to be able to feed the heart. Does that make sense?
It does. So the body is purposefully putting plaque on the arteries at what we consider as being the worst possible place. We don't really have a good. It appears to me that the medical establishment doesn't seem to have a good grasp on the function.
No, they don't. And it annoys me, I read so many papers, and the whole time I'm reading the paper, I'm saying, why? I'm always asking, why is it doing this? Because I believe biology always has a reason. When they write the paper, they just report, well, this happens, and then that happens, and then this happens. They're not interested in asking why. I'm so puzzled by that. It seems like the researchers have forgotten how to ask why. And every time I see something, I want to understand, okay, biology is doing this for a good reason. What is it? The same thing with cancer, for example. Prostate cancer produces cholesterol sulfate. It's a marker of prostate cancer. Why is it doing that? Because we desperately need it. And breast cancer produces estrogen sulfate. So they're producing these, either cholesterol sulfate itself or these other molecules that are very much like cholesterol sulfate in order to supply them to the body, because if the body doesn't have enough, there's going to be a blood meltdown. So, the body's deciding, I better have a tumor here to help out the system because we're so desperate. We better do something. And, maybe a breast cancer tumor is better than to have a thrombosis or hemorrhage, and die from a blood disaster, which is what it's protecting you from. Okay. It makes the artery wall healthy if you've got enough sulfur in there, sulfate.
Right. Why don't you take an MSM sulfur supplement regularly?
I don't take it. Yeah. I'm on the fence on that one. If you help put me at gunpoint and said, take another supplement besides turmeric, it would probably be MSM that I would choose.
Okay.
And there's also, I don't like to take supplements, as you gather. Part of it is because the gel cap is gelatin, which is likely to contain glyphosate. So I don't want to take the gel cap.
Really? Gosh.
Yeah. So you got to worry about that. You've got to worry about glyphosated products. One of the ones that really worries me is tampons. Tampons contain glyphosate. And we have an epidemic in PCOS, polycystic ovary syndrome. That might be connected. I haven't done enough research to say for sure, but I just have that as a red flag. And
gosh, is that because of the cotton?
Yes, glyphosate is in many cotton products. I'm really worried about cotton. Actually, I've been trying to I'm trying to get something going with organic cotton clothing, because I really think that's a message people need to get out. I've been trying to buy, you can occasionally find organic cotton clothing. I have some organic cotton t-shirts. I have an organic cotton dress. You know, my grandchildren, we buy organic cotton clothing for them. And you can get it. It's not very common, not very readily available, but there are products. Cotton is a mess. I mean, it's not just the glyphosate. It's got so much stuff in it. It's just really toxic. It has to be toxic, I think. It's killing the farmers, you know. I mean, they've got this big problem with the, there's a worm, I forget what it's called, but there's a worm that's been causing an enormous amount of problems with the cotton, with the GMO Roundup Ready cotton. And cotton is also not a food product, even though you get food out of cotton, because cotton is used to make cottonseed oil. But because it's not considered a food crop, it doesn't follow under the food regulatory restrictions. So they can use more toxic chemicals on the cotton crop, and they do.
Yes, yes. Does do the chemicals wash out?
I don't know. I mean, I suspect it doesn't with respect to the glyphosate, because it's probably built into the cotton fiber because of the fact that glyphosate goes into protein. So it could eventually, your skin could have some enzymes that could break down the proteins in the cotton, and then that could release the glyphosate, and then it could come into your body. It seems to me that would be possible. Now, the research hasn't been done to say that that's actually happening, but I can't see why it wouldn't. It seems plausible to me, you know?
It does seem possible. And you've got your body temperature and the acids and the other solvents.
Yeah, there's enzymes that are released in the skin. And I mean, you could, I think, break it down. It's plausible. I wonder about the kids with the eczema. I mean, a lot of kids these days have eczema problems. If they're wearing cotton is a good choice. I always bought cotton clothing for my children, you know? Same. And now you say, oh my God, the cotton contains glyphosate. You start to get a little paranoid about living. You know, what can I do to avoid this thing? It's really quite impossible. It's very difficult. And of course, you want to make sure not to use glyphosate on your lawn. Tell your neighbors not to use glyphosate on their lawn. You can put up with the dandelions or pull them out by hand. I mean, really, it's not worth it.
Yes. Oh my goodness. The second half's supposed to be the fun stuff. Okay.
We're not doing so well. I'm sorry about that.
We'll try and make a recovery. Which vegetables are rich in sulfates, natural sulfates?
Yeah, so garlic, I mentioned many times. Yes. Onions are good. I love onions. Cruciferous vegetables. So broccoli and cauliflower and Brussels sprouts, those are all great sources of all those vegetables. Of course, meats. Meats are very important. In fact, meats contain taurine, and taurine is a really fascinating amino acid. Super important, and also problematic with respect to glyphosate. Glyphosate causes trouble with taurine. But taurine is the only sulfonated amino acid. So this relates to our sulfur story. It's really a interesting molecule because it has sulfonate, which is, as you can hear from the name of it, it's almost sulfate, right? It just needs one more oxygen to become sulfate. But taurine is inert with respect to the human cells. Very, very interesting. The human cells are unable to break it down. And we store tons of taurine in our... Taurine, by the way, is found in fish and seafood and grass-fed beef, you know, so animal-based products.
Okay.
And it's very, I think it's probably, it may be even more important from the fish that you get taurine than it is that you get the, they talk about the healthy fats in fish.
Yes.
But I think the EPA, the DHA, the polyunsaturated fats that you have in fish, which they think are so important, I think the taurine may be more important in the fish. It's high levels of taurine. And the brain, the heart, and the liver all store tons of taurine inside them. They hog taurine. They like a squirrel. They squirrel it up and they pile lots of taurine. And I think that taurine is used in an emergency when there's a severe sulfate deficiency. It's released. It is in fact true that it's released. Like in a heart attack, taurine is released from the heart. And when you have encephalopathy, like you have a brain inflammation and you've got swelling in the brain, taurine is released from the brain. And I think that the microbes are pitching in to help the human cells, which are incompetent. It's turning the taurine into sulfate. So it's very, very interesting. I think taurine is a storage mechanism for sulfate in a way that it's inert only because the human cells don't possess the capability to process it. So it makes it safe as you just put that in there and hang on to it for a rainy day. Once you're desperate because the sulfate's so deficient, you can improve the situation by having a heart attack, which is not a great way to go, but it is going to help you out. If you have a small heart attack and you don't have any heart damage, you're probably better off after the heart attack than you were before. And that's very interesting. And I think autism can be characterized as a sort of chronic low-grade encephalopathy, where the brain is swollen all the time, but only a little bit swollen, because it's working to try to use this taurine to make sulfate because of lack of sufficient sulfate supplies.
So do you think that autism may be reversible by increasing your intake levels of taurine and the sulfates? Really?
Yes,
You think,
absolutely.
wow.
I mean, in fact, autism has been reversed, and it's a complex process, but there are clinicians who have reversed autism. I was so happy the first time I heard that, because I was for the longest time not knowing whether it was possible to reverse it. I have a friend who claims she even reversed autism in an adult, which was really amazing, because you do find the older the child is, the less likely it is to be able to reverse it.
Okay.
But I've talked to these clinicians. I'm working with them, actually. We're all sharing ideas and trying different things. They're very bold because they're working with a very very severely damaged population, and they have to take risk to try things. And when things work, then they learn from that, and then they use it again. So they have failures, right? They can do damage. I mean, it's very difficult to get to a point where we understand how to heal autism. But I think that we have come a long ways in understanding that in this alternative medicine clinical community. And they are treating autism with all kinds of interesting things. Of course, number one is organic diet. And you've got to straighten out the gut microbes, but you can't straighten them out unless you get rid of the glyphosate. That's the number one step. But then there are ways to restore the function and bootstrap things up. So once you can heal the gut, then the gut can start to heal the body. So when the gut's broken, the body is in bad shape. First, heal the gut. And then you can go from there to heal the brain. And it certainly involves sulfur, but you have to be careful because these kids can be allergic to sulfur because sulfite is extremely toxic. So you have like sulfite in wines. Some people are sensitive to sulfites in wines. Yes. And you have sulfite on dried fruit. Sulfite is extremely toxic, and the microbes have enzymes that very quickly turn the sulfite into something else, either into sulfate or into methionine. And those enzymes are busted by glyphosate, both ways. So sulfite becomes toxic, and methionine is deficient, sulfate's deficient. And you're stuck because you can't get a big enough supply if you have to go through sulfite along the way. Sulfite's going to cause trouble and destroy the gut. So you've got to get rid of the glyphosate, and then you can go from there with all the healing, taking things like curcumin, polyphenols, so eating a lot of foods that have these sulfate carriers, I call them. And these are molecules that can transport sulfate from the gut to the liver. You fix the liver, you fix the bile acids, and then everything else starts to fall into place. You can now start to deliver sulfate to the brain. Serotonin delivers sulfate to the brain, but serotonin is a product of the shikimate pathway, so you're going to be in trouble with serotonin as well, and that's going to provide a deficiency of sulfate in the brain.
Gosh, sulfate's good, sulfite's bad.
Yeah, I know. That's what's so horrible, isn't it? They're like just off by one oxygen.
Isn't it? Yes.
It's so interesting. Biology is just absolutely fascinating. You can tell that I'm totally hooked.
Yes, it's come across, which is great. And gosh, it's so deep as well. But it all started from a business decision, didn't it, to increase the rotation speed, I guess, of crops by making the old crops die off faster, clearing the grounds for...
Yeah, and of course, making it much easier to grow crops. You can have this huge farm and with very little management, very few people, just spray everything with poison and kill off the weeds. The crop has been protected by this GMO. It's got this bacterial gene that keeps it safe, but it doesn't keep it from taking up the glyphosate and getting it into the food supply. That's the problem.
What to do? Okay, now the one other question that's come in is regarding cancer. Is cancer basically the ultimate outcome following immune suppression due to sulfate deficiency?
Well, I think so. I mean, basically, immune suppression is going to drive you towards Well, so you have all these autoimmune diseases, which are because the immune system's on fire, and they're actually producing sulfate. So, for example, gout. We wrote a whole paper on gout. And gout, you can see what's going on in the gouty joint. Gout is like this, you know, your big toes on fire, and it's very painful. Your gouty joint is actually producing cholesterol sulfate and delivering it to the immune cells, which is going to strengthen them. The immune cells are sick because they don't have enough sulfate. They can't clear the garbage. They can't clear the viruses even because they don't have enough sulfate.
Gosh.
And so they need sulfate desperately. And these rheumatoid arthritis, for example, you know, and I suspect Alzheimer's, all these things are helping the blood to be supplied with sulfate through sacrificing some organ. And the cancer is doing basically the same thing. The cancer is taking the heat of all that fire, of that superoxide that you need for the inflammatory response. The cancer is saying, okay, good, we're going to go ahead and handle that. It's going to hurt the cells. The cancer cells get damaged. That's why they get, you know, mutations. They get genetic mutations. They become cancerous because they're getting hit by all this inflammation. But they're making sulfate. And that sulfate is rescuing the blood so that it can circulate without causing a blood clot or bleeding, right? So hemorrhage and thrombosis, that's what, you know, elderly people face. They're walking a tightrope between hemorrhaging and blood clots. And they're taking Coumadin. I mean, they've got all these things that they're taking to try to thin the blood and prevent the blood clots, which can end up with a hemorrhage. You know, they don't know how to balance that. And the reason is because there's not enough sulfate. So you're going to have different ways, different strategies that different bodies will use to supply the sulfate to the blood in the face of this enormous deficiency that glyphosate has caused.
It sounds like the solution is actually quite simple. If we're doing things the hard way, well, the way that the drug way.
I know. All you need to do is ban glyphosate. You know, stop manufacturing it. It would make the world so much more beautiful.
Do you think that a shortage of sulfur in your body contributes to age-related problems such as sagging and wrinkling of skin? I'm just told about this apparently. Stiff muscles and painful joints?
Yeah, and I suspect the skin part, I haven't studied that one specifically, but I suspect that's true. Really? Certainly the achy joints. I mean, it's just really striking to me how much that involves inflammatory. So there's an inflammatory response in the joint. And actually a whole bunch of different activities go on. We wrote about it in detail in this gout paper. You could probably just Google Seneff gout and you would find it. And it's really fascinating. But as I said, the literature's already there that explains all of these processes that are going on. But the literature, the people who are writing literature are not thinking in terms of making cholesterol sulfate. If you think in those terms, all of a sudden it makes sense what all is going on in that gouty joint. And it's doing everything it can to make cholesterol sulfate, to supply it to the immune cells, which are coming in and saying, thank you very much for the cholesterol sulfate. And they're going on their merry way, now fixed, because they've got that sulfate that they needed to maintain a healthy immune system.
Okay.
All these inflammatory diseases and all the joint pain, you know, and we've got, of course, an epidemic in opioid drug overdose, right? So many people are aching all over the place. And I see people limping on the streets all the time. It just breaks my heart. And I think the glyphosate is causing that. Gosh,
one thing, the cause of many illnesses.
It's amazing. It's truly amazing. You know, and people say, and I say, glyphosate is correlated, you know, strongly correlated with all these diseases. I have this huge list, right? And they say, oh yeah, well, correlation doesn't mean causation. That's what they always say, you know. But you tell me, what is it? If it's not glyphosate, what is it? Because all these things are going up exponentially. It has to be something. And glyphosate to me is really most logical answer.
We've got you know, radio waves now, which we didn't have. You know.
I know, that's true. That's another one, and I'm concerned about that and looking into that one as well. There's only so many hours in the day, so you have to sort of focus on one. But I'm glad people are looking into EMF, and I do think they're part of the problem. And they're related because the glyphosate is preventing the body's electrical system from being healthy, which makes it more susceptible to electrical noise. So they're connected.
Okay. And it's like you've got to take a more holistic view of research, not just of health, but also of research. So, because these things are tied together. You've got your sulfates and you've got your, you know, other things, you know, Wi-Fi and everything. And they all sort of work together to, you know, to
destroy us.
I didn't want to say it because we're in the final half.
We're supposed to be happy.
not to do such not to do such good things. But how do people know if they're consuming enough sulfur? Is there any sort of easy way of determining?
Yeah.
whether their sulfur intake is sufficient.
Yeah, I would say if they feel good. I mean, certainly if you have achy joints, that's probably an indicator
Mm.
of sulfate deficiency.
Yes,
If
yeah,
you have a
that's
leaky gut, that's an indicator. If you have heart
okay.
issues, that's an indicator. So different genetics and different microbiome mix is going to cause a different diet. All those things are going to cause a different way to try to get around the sulfate deficiency problem. But all of the ways are bad, and you don't know which one to pick. You'd rather have
Mm.
none, and you need to work really hard on keeping your sulfate supplies up without damaging yourself with sulfite. So that's the tricky thing.
Right. Now, if you ate organic food, it's good. If you go out in
Very
sunshine, it's
good.
even
Yep.
better.
Yes.
Sunshine's good for the soul. But there's one way, it's hard to, like it must go into the water system as well.
The glyphosate.
Yeah,
Yeah,
so how,
I know. That's true. I mean, you can actually get water filters, and a lot of them don't work for glyphosate. So you have to, what
gosh,
is it? It's the reverse osmosis filter, which of course strips out all the minerals, which is not good.
yes.
So you have to put the minerals back in, so it's messy. And you can get your water tested for glyphosate, or move to a place where the water's good. I mean, there's those kinds of decisions you could make, which is bigger decision, but it might be worthwhile. If you live in a place where the water supply has a lot of glyphosate in it, I would say move. I would definitely say move.
Wow, because there's no escaping it. But would a carbon filter remove the glyphosate?
Apparently not. I mean, only the reverse osmosis. I heard a whole lecture
Oh
on
my
that at a
goodness.
meeting that I attended, and reverse
Yes.
osmosis is the only thing that takes the glyphosate out, which is too bad because it takes out the minerals. And in fact, sulfur containing water is extremely healthy. And countries where there's a lot of sulfur, like Iceland, people are healthy there because of the sulfur that's in the water.
Right.
So,
Right.
and this reverse osmosis will take it out. So, it's you can't take out the good with the bad without also taking out the good. So you have to be careful.
Didn't Finland have they voted one of the happiest countries in the world? I think they
Oh, Finland has a lot of obesity problem. But
no,
Iceland is the one I said.
oh, sorry, Iceland. Sorry.
Iceland has incredibly healthy people. They live a long time, and they
Yes.
actually a very interesting story about that. There was an eruption in the late 1800s
Yes.
of the volcano, and it kind of it kind of spilled out all over the land, and a lot of people left, and they went over to northern Canada. And so then there was someone who studied the people who had come from Iceland and were now living in northern Canada versus the people who stayed behind. And they found that the ones who moved to Canada ended up with all the cardiovascular disease and diabetes that other people have, whereas the ones that stayed behind were still healthy. So they were eating the same diet and they were living the same lifestyle, but they did not have the sulfur.
I was going
They
to
didn't
ask
have the
whether
sulfur.
if they'd adopted the Canadian diet, which is possibly close to American diet, which is
well, this is 1800s. So.
Oh, okay.
Yeah,
Okay.
and they continued to eat fish. They were doing basically the same diet in northern Canada, but they got sick.
Oh, okay. So it's a bit of a smoking gun, then, isn't it?
Sulfur is so important. I think it's key, and I think it really the Mediterranean diet. I think really maybe simply you have to be in the Mediterranean because there's a lot of sulfur there. You have the Vesuvius. In Italy and I think Spain are major suppliers of sulfur to the world. They have a lot of sulfur. So the sulfur in the water may be the key thing with the Mediterranean diet that's keeping them healthy.
Okay. You've told us that sore joints are one sign of being low in sulfurs. Is there a test for glyphosate that one can take to
Yes,
see?
you can get a urine test for glyphosate. And you can actually order that on the web. There's websites which you can go to. I think my Labs for Life, MYLABSFORLIFE, I think .com. They offer a test for glyphosate, which I think is something like $100.
Right.
And you can do a urine test, a water test for glyphosate. And of course, it's a short-term test. So one thing unfortunate is it's really mostly looking at whatever exposure you had in the last 2 weeks.
Okay.
So you'd have to keep on getting tests to find out. It would be a little tricky to know. One number might not be that useful, but it would be good to know if it was 0, you'd be very happy. So, below threshold.
I guess there'll be one courier package that the courier driver wouldn't want to break in their van. So, would there be is it like, I mean, I live in China. It may take quite a while for the sample to go to.
I know. I don't know if you have something in China. You might. Have you looked? I don't know.
No, I've learned so much. I've got, always after Sam's, I've got to do a bit more research. But no, but my question was really, is there a life, like, is it got to be done within a certain time from being fresh, if
Yeah,
I
that's a
need
good question. How long does it last? Would
Mm,
imagine
that's what I
so,
thought.
because if there are microbes in the urine, they could be breaking it down, right?
Yes,
So I
yes.
would imagine it would need to be fresh, yes.
Okay,
But I'm
okay.
not sure about that.
Okay, we've covered the association between glyphosate and autism, or they talk about Lyme, chronic fatigue syndrome,
Yes.
fibromyalgia. Are they all linked together, are
I
they?
think they're all kind of the same disease, actually, including autism. They're all intimately connected to the widespread damage that glyphosate does to the body, and in particular the sulfate deficiency problem. I think they're all connected. They're all have a common thread with that.
Okay, okay. Now, when I introduced you, I used the term NLP techniques for
Oh
searching the
yes,
databases, and I did
you don't know
say
what NLP is.
I'm totally clueless.
Natural language processing. Natural language processing. So it means actually taking human language and running it through a computer program that parses it. It's called parsing, where you build a structure out of that sentence in order to understand it syntactically and semantically. Does that make sense?
It does, it
Yes.
does. But I'm not sure that I understand if it goes much further.
But so then what it's doing is so basically allowing the computer to read. It's like teaching the computer to read.
And so it's like a macro study.
Well, and so
Looking,
using NLP technology means that you're grabbing. So, for example, I can give an example. Like we did a study on statin drugs, and I
yes.
published that several years ago. I think 2011, I think was when we published that. And we got online posts of people's descriptions of their reaction to statins. So they just wrote about their experience with statins, and it caused all these muscle aches and pains, and then they stopped the drug and then went away, and all of that. So you grab all that text and you run it through this NLP stuff. And then the computer looks at all these reports from all these people, and it compares it to all these reports about all these other drugs that they're taking. And it says which ones are showing up. You start to get a sense of a set of side effects that are commonly associated with statin drugs compared to the other drugs that these people are taking. And so in that paper, we report out on all these things, which includes like dementia and Parkinson's disease. And of course, muscle aches and pains were humongous. I mean, huge amounts of muscle aches and pains.
Yes.
And weakness, muscle weakness, and even, things like road rage, uncontrollable temper and things like that. So we found all kinds of things that
Yes.
people were observing associated with statin drugs compared to their observations that they reported on the other drugs they were taking.
Well, this is one thing that's quite remarkable with antistatins, but something which is pretty much common knowledge now. It wastes your muscles, causes muscle aches and
Yes.
pains. It's not an event that it's maybe 1 in 100. It's one in
much,
one.
much
1 in
higher.
1. One
Yeah,
in
it's one of
one
those
almost.
things where they managed to very carefully design their studies so as not to see it.
But it's so obvious now, just
It
through,
is. Yeah.
So why is nothing being done about it? It's still
I
being.
don't know. I mean, it's a moneymaker. It's unbelievable to me that statins are even still on the market. I think they are extremely toxic and right up there with glyphosate. It's so sad. I think a third of American adults or something ridiculous like that, or maybe the Americans over 50. I'm not sure of the exact number, but a huge number of Americans are taking statins. I think they're all making a mistake.
Yes.
I wouldn't recommend it to anybody. I mean,
No.
it's disrupting cholesterol, and cholesterol is so important for the body, especially for the brain.
Mm.
And we have an epidemic in Alzheimer's. It's going up exactly in step with autism and exactly in step with glyphosate. And meanwhile, we're taking statin drugs, which are depriving the brain of cholesterol, which is probably super, super important for the nerves. And it's just stupid. It's just really, really crazy. And of course, we're interfering with the supply of cholesterol sulfate to the heart, which is causing heart failure. So we maybe we prevent a heart attack, but we don't prevent the big ones. And in fact, we make the big ones more dangerous, I think, when you're on a statin. And we cause heart failure because the heart's not getting enough cholesterol sulfate.
Right. I don't know how the medical system is going to change now, because everyone has to be registered to become a medical practitioner, and the registration process is purely allopathic, which is statin and anti-cholesterol drugs, and it's just
Yes, it's an insane system. I think I predict that the medical system in the United States will collapse. I think it's going to collapse. I hope within the next 10 years. I think there's just so much going on right now with more and more awareness. The sort of mainstream medical system is on sand. I mean, it is not founded on anything that makes any sense, in my opinion.
Right, right.
And meanwhile, you have all these alternative professionals, alternative medicine professionals who are doing great work and solving huge problems like reversing autism. The doctor sees the autistic child and hands them a drug, right? And they say, this is hopeless, you're never going to recover, but take this drug. And it's just probably going to make it worse down the road. It may alleviate symptoms in the short term, and same thing with Alzheimer's, alleviate symptoms in the short term and make it worse in the long term. That's what the drugs do, pretty much, I think, categorically. And we need to get away from chemicals. Anything that's not natural, to me, by definition, is not good for you. I will not take something that's not natural. That's number one.
Right.
And so natural, so that all the homeopaths and the functional medicine, all those folks, they're based on natural products, and nutrition and food and diet and sunlight, all these sort of walking barefoot on the beach. I mean, all these very basic natural ways to heal your body,
Walking barefoot on the beach, is that for the sunlight or just the...
Yeah, well, the sunlight's good too, but it's actually for the grounding. That's a whole other thing with the electricity, negative charge. The body is basically negatively charged, but we lose negative charge because of the sulfate, because sulfate carries negative charge. But the grounding allows the negative charge from the earth to come into the body and provide the body with negative charge. So walking barefoot on the beach in the water is one of the best things you can do. You've got the sunlight, you've got the sulfur, because there's sulfur in the air. If it's the ocean, the air is rich in sulfur. So you're breathing the sulfur. Even the skin might be able to take that hydrogen sulfide gas and turn it into sulfate with the sunlight. And you've got that negative charge boost from the ground for the electrical supply to sort of make the water happy. Everything is beautiful. So walking on the beach, there's a good happy note to end on. It's a fun thing to do. Take a walk on the beach, bring a companion, have a nice chat, walk down the beach, walk back, and you will be healthier when you're done with that.
I knew we could do it, Stephanie. Well, that concludes our 33rd Summer. Stephanie Seneff, thank you so much for being with us. Thank you, my pleasure. It was a complex subject. There are times when you did lose me, but
I hope I didn't lose all of the audience. But
you've got passion, because you've studied things at depth, and you've joined many dots.
I know, many dots. That's certainly true, and I'm joining more every day. It's such a profusion of dots, and it's an orgy. You really get hooked it's fun. I mean, the whole research is just so fun because there's so much that works and makes sense and ties together, and you just feel like you're onto something huge. And it's sort of you become obsessed. You definitely become obsessed when you join this game. And I've got some companions that are helping, and we're all working it out, and we're making good progress. I have hope.
A couple of days ago, you mentioned that you had a Facebook
yes
group. Have you got any websites you'd like to point people to? Perhaps if there's a scientist watching this video and they may want to contribute or have some ideas.
You could look at my website at MIT, which is people.csail, CSAIL. That's my lab, Computer Science and Artificial Intelligence Laboratory, .mit.edu/Seneff, my last name, SENEFF. I have a bunch of stuff posted there. It's not a very pretty site. It's very basic, but all my papers are there, or all my recent papers, So there's a lot. You could really learn something about glyphosate by reading some of my glyphosate papers. And I have some links to some other people's things, and I have a lot of videos too. If you just remember my last name, fortunately it's quite rare, SENEFF. If you can learn that word and search it either in YouTube or on the web, you'll find a lot of stuff, various interviews like this one, and podcasts and slideshow presentations, lots of stuff off my work. And then, of course, that will branch you out into everybody else's. Each of my papers has a few hundred references, so it can keep you quite busy. If you decide to go down the route of reading papers, that one will keep you busy forever. So,
how do you find the time to do this?
Well, I'll tell you one thing is I have a wonderful husband, and he really takes
Yes.
care of me. He's a
Good.
wonderful, and he's doing all the cooking and all the organic food. He's a very good cook. He takes care of me very, very well. So he optimizes my time that I can spend working, and I really appreciate that.
Thank you for your time, Stephanie. Thank you
Thank
so
you.
much. Okay, and goodbye, everyone. Facebook and now Vimeo and everywhere else. Thank you for your questions, and thank you for watching. Goodbye.
Thank you. Bye.